Lesson 314, polynomial division. So today we're going to work on dividing polynomials. Possibly in Algebra 2, you worked on some polynomial division, where you had a linear divisor. But what happens if the divisor contains an x squared or an x cubed? So we're going to work on two different ways to divide polynomials today. There are two methods. The first method that we're going to talk about is an area model. And the second method that we're going to talk about today is using long division. So when we use an area model, using multiplication, I'm going to start by multiplying 2x cubed times x to get 2x to the fourth. 2x cubed times negative 3 is negative 6x cubed. And I'll continue to fill in my area model. And then we add up all of the like terms inside of the area model. So we're left with 2x to the fourth, negative 5x cubed, negative 5x squared, 7x minus 3. If you look at the patterns in the area models, the 2x to the fourth comes out to the top. Combining like terms for x cubed, combining like terms for x squared, combining like terms for x, and then a negative 3 at the end. So if we try one more multiplication problem using an area model, again, fill in each square of your area model by multiplying length times width. Zero times anything is 0. And then add up like terms. So I have 2x to the fourth plus 5x cubed plus 2x squared minus 6x minus 3. So I can use area models to do multiplication and get the resulting products. So working backwards, what times x plus 2 is going to give me that product? So I'm going to build an area model to start. So I have an x plus 2, and I know my resulting product is x to the fourth minus 1x cubed minus 4x squared plus 8x plus 8. So I need to now work backwards to fill in my area model. I start by moving my x to the fourth into my top square. And then I think about, all right, what times x is going to give me an x to the fourth? X cubed times x gives me an x to the fourth. X cubed times 2 gives me a 2x cubed. Now looking at the pattern from earlier problems, I was adding across the diagonal in each instance of x. So looking at this problem, I can say, all right, what plus 2x cubed is going to give me a negative 1x cubed? A negative 3x cubed plus a 2x cubed is going to give me a 1x cubed. And then continuing to work backwards, what times x gives me a negative 3x cubed? A negative 3x squared. And multiply to fill in my area model. Now, what can I add to negative 6x squared to get negative 4x squared? A 2x squared. Working backwards, what times x is going to give me a 2x squared? A positive 2x. And lastly, what plus 4x is going to give me an 8x? 4x. So my missing component in this problem is x cubed minus 3x squared plus 2x plus 4. So that's method 1, using an area model. I can also use long division, because what I'm really saying in this problem is this divided by x plus 2 gives me what? So setting up my long division, what times x gives me an x to the 4th? X cubed. So multiplying x cubed times x and x cubed times 2, and then subtracting x to the 4th minus x to the 4th is 0. Negative x cubed minus 2x cubed is negative 3x cubed. So what times x gives me a negative 3x cubed? A negative 3x squared. Multiplying negative 3x squared times x, and multiplying negative 3x squared times 2. Bringing down that 4x squared. So negative minus a negative cancels the x cubed terms out. Negative 4x squared minus a negative 6x squared is a positive 2x squared. Bring down the 8x. Two x times x gives me 2x squared. 2x times 2 gives me 4x. 8 minus 4 is 4x. So lastly, 4 times x plus 4 times 2 gives me a remainder of 0. So I have found the exact same solution using long division or an area model. Pick whichever method works best for you. So going through another example like this, let's build an area model first. So I have an x minus 2. And I want to know x minus 2 times what gives me a solution of x cubed minus 5x squared plus 0x's plus 8. Starting with x cubed in my area model. X squared times x is going to give me the x cubed. Negative 2 times x squared is a negative 2x squared. A negative 3x squared plus negative 2x squared gives me a negative 5x squared. So a negative 3x times x gives me negative 3x squared and a positive 6x. So to get 0 x's, I'm going to have a negative 6x plus 6x. And in my last section here, what plus 12 gives me 8? So a negative 4 in this case is my remainder. So when I'm writing my solution, the answer to my division problem is x squared minus 3x minus 6 plus a negative 4 over x minus 2, because this shows my remainder. Doing this exact same problem using long division, how many times does x minus 2 go into x cubed minus 5x squared plus 0x plus 8? Make sure you're filling in your 0x. I'm going to start by multiplying by an x squared, because x squared times x is x cubed. X squared times negative 2 is negative 2x squared. Negative 5 minus negative 2 is a negative 3x squared plus 0 x's. So I'm going to need a negative 3x subtracting 0 minus 6 is negative 6x. Bring down the plus 8. So I have a negative 6x plus 12. 8 minus 12 is a negative 4. So I have the exact same remainder. So plus a negative 4 over x minus 2. So I've added in your notes from your book the process for long division and the process for using an area model. You pick whichever works best for you, and you can do both methods to double check your answers. So again, which method do you prefer? Either an area model where I have a 2x minus 1 and a 6x cubed minus 5x squared plus 5x plus 8. So I have to work backwards to figure out what times 2x minus 1 gives me this solution. So I start with my 6x cubed. Working backwards. Oops. -1 times -1 is a positive 1x. So what plus 1x gives me 5x? A 4x. And 2 times 2x gives me 4x. And a 2 times a -1 gives me a -2. So what plus -2 gives me 8? A 10. So that's my remainder. So I write my solution as 3x squared minus 1x plus 2 plus a remainder of 10 over 2x minus 1. Showing that exact same problem using long division. So 2x goes into 6x cubed, 3x squared times. -5 minus -1. Oops, sorry. Minus, that's a 3. 3 times -1 is -3. So -5x squared minus -3 is a 2x squared. -2x squared. So I need a -x to give me a -2x squared plus x. 2 negatives make a positive. So -2 minus -2 is 0. And 5 minus 1 is 4. Eight minus -2 is a positive 10. So I get the exact same solution using an area model or long division. Practice problems for this section is 314. Make sure you are emailing me or bringing additional questions to class. Have a good day.